Hi everyone, this is Ishika Bhattacharjee, and today we are actually learning Introduction to Natural Language Processing. So, first of all, let us start that what is NLP? What is Natural Language Processing? So, it is basically a branch of artificial intelligence that helps computers understand, interpret, and generate human language. Now, human language is very complex in itself. Suppose there is a sentence that Ram's dog actually died and he told his father. He is very sad. Now, in the second sentence, he is very sad. You can't interpret who the he is. Is Ram very sad or his father is very sad, right? So there is these kinds of complications in human languages. So we need our machines to understand these kinds of complications also, so that it can work better. And like we communicate with another human being, we can communicate to our machines also. So this is the whole goal of this natural language processing. Now, natural language processing actually comes under conversational AI, right? Where we can have conversations with our machines, with the AIs we are using. So for that, natural language processing is a kind of tool. Okay. So suppose in the chatbots, what we have right now is that we can ask it a question like, tell me the fare of this train, and it will give you the fare amount, right? Or like this system, like one question, one answer, one question, one answer, these kind of response. But in humans, we don't talk like that, right? We actually have conversations. So our motive is to have AIs that can actually conversate with you, right? So that's why I'm NLP. So basically, it comes under artificial intelligence for sure, and it understands, interpret, and generate human language. So a formal definition would be like NLP is a combination of linguistics, computer science, machine learning that allows machines to analyze text, understand meaning, extract information, respond in natural language, and communicate like humans. So why do we need that? Like I told you, because our natural languages, humans' natural languages, are English, Hindi, and Bengali. But computers, not Hindi, English, and Bengali, there are more languages. Some of the languages are there. Now, but computers, they don't understand any of these languages. That understand only binary, that is 0 or 1. So it understands a language that is basically numbers in the form of 0 and 1. So NLP here acts as a bridge to gap this language barrier. Like we use human languages and our computers use binary. NLP actually gives us the chance to bridge the gap, right? Now let us see what are the applications so that you have a good understanding that why are we going to use NLP, right? So there are chatbots and virtual assistants like ChatGPT, customer support chatbots. These uses NLP to understand customers' queries like track my order or play Arijit Singh songs. Now, when you order something on Swiggy, suppose you ordered a burger and it showed you that it will arrive in 30 to 35 minutes. Now, 1 hour actually have been gone and still your burger haven't reached you. So what do? You go to their customer support and there is one type that chat with our assistant. Now there is the chatbot, the conversational chatbot they are using to actually meet your queries and give you some responses accordingly, right? So if it is not able to sufficiently answer your query, then it gives the chat to their actual customer executive, then they will chat with you. But before that, all the conversations are handled by this conversational AI in Swiggy. So it will just take you that your order is actually ready. Give us some time, and it will reach to you, right? So this kind of things is happening in the chatbots or virtual assistants. Like in Siri also, you just say Siri, play this music, and Siri plays this music. So this kind of applications are in these kind of applications are actually based on NLP. The second one is sentiment analysis. So these businesses use NLP to understand customer emotions from the tweets, reviews, or feedback. Now, if we have the customer emotions, we can actually use this in our case. Like we can advertise them that kind of product that actually is related to their emotions, because emotions plays a very crucial role in businesses, right? Like example, Zomato detects if the customer is angry and it escalates to human agent because it can't then uh, talk with the human because the anger how it is going to handle because it is trained on some point that it will just answer your query in that way. So this is a huge domain to work on to have AIs talk like humans. Second example would be Amazon checks if product reviews are positive or negative. Now, next one is machine translation. So, Google Translate uses NLP to convert languages. Like whatever we write in Google, it can give us back the translation in any language. These functions also use NLP. There are more like text classification, speech recognition, recommendation systems. I'm not going to get deeper into that. These are the applications based on NLP. Right. Now, how NLP works? These are the 5 steps on which the NLP works. Actually, there are 4 steps. The last one is the implementation flow. So, first one is text pre-processing. Next one is text representation. Next one is model or algorithm used. And then fourth point would be natural language generation. And at last, I'll show you the implementation flow of taking a simple example. Now, let's see text pre-processing. Now, like in any data science project or any machine learning project, you need to first pre-process the data, right? Similarly, we need to pre-process the text before actually applying any algorithms on it. So what do we do in this pre-processing? The first step is tokenization. So there would be sentences and sentences in the paragraphs for us as data, right? So what we do is we tokenize the sentences into smaller words or tokens. Like chatbots improves customer service. So every word is the token here. This whole sentence is taken out word by word. So chatbots improve customer service. This is called tokenization. Next word is stop word removal. So there would be words that actually didn't make or break the sense of the sentence, right? So those words are actually called stop words. We can just remove them, and after removing that, also we don't get any changes in our sentences, right? Like a, the, is, and, of, to, these kinds of words. So these kinds of words are actually removed from the whole paragraphs because they don't add any meaning. With if they are there, it's good because grammatically it should be. But for our pre-processing, we don't need those words. So we just focus on the keywords or important information in the text, right? So we can remove them. The next is stemming. So stemming is actually reducing words to root form, like the crude form. Suppose there is running runs, or run, or playing plays, played, and we can just have all these words as running runs as run, playing played plays as play. So it is reducing words to its root form. So we can just use the play word for every uh, other word relatable to play, right? Now there is lemmatization. So it is more meaningful root extraction using grammar. So we can do that or don't do that. It's up to you, but it's better to use that so that we have the proper raw text for the next steps. So we are getting the raw text and we then pre-process this text. So after doing all these steps, we can get a proper information data, informed data, right? So like we can use good for better, study for studies, like this. After that, also we can do what that we can convert the higher or the capital letters into lower cases, the upper cases into lower cases for more convenient. Like we just can change the whole paragraph into lower case. We can work on it. Also, we can remove the commas, full stops, these kind of things to get a proper data set with most of the information in it and not the noise. Correct? Now let's next we move into text representation. So there are some techniques for text representation. Now, why is it important? Because, like I said, the machines are not able to understand the languages that we are speaking or we are providing it, right? So we need to have the language that the machine understands. So we need to represent these texts that we are giving it in a way so that the machine can understand. So basically, we need to vectorize all the texts to the machine so that it can easily understand it. So there are some techniques like bag of words, TF-IDF, and word embeddings. So what is this? Bag of words actually represents text as word count. Like there are two sentences. I love AI. AI is powerful. Now in this two sentences, there are some keywords, the most important words that are unique. So the vocabulary would be I love AI is powerful. Now there are two AI, but we can consider just one, right? So this is bag of words. Next is TF-IDF, term frequency inverse document frequency. This is actually vectorizations, and we use TF-IDF mostly in all the NLP codes we are doing. So it measures how important a word is. It gives a weight to every word, that how important the word is, and accordingly we actually vectorize it. Now rare words are more important, common words less important. Suppose invoice is more important in finance documents. So it will take that word and vectorize it in such a way that it gets the highest weight. Correct? Now next is word embeddings. So it actually converts texts into vectors, semantic meaning, like king, man plus woman is queen. So like king minus man plus woman is equal to queen. So it actually word to vector concept. It is taken from the word to vector concept. So this is word embeddings, where we normally convert the text into vectors. Correct. Next is NLP model. After this pre-processing, we get our data and we choose the model we need to apply for the particular task. We can use for classification models, sequence models, or named entity recognition. So these models are then applied, and very complex things are going on inside it. This is the basic architecture of how is going to happen, right? And inside of these architecture, inside of each step, there is going a lot of complex problem solves. Correct. Now we can use these applications or models for the particular task. And at last, we take the natural language generation. So the machine creates human-like responses. After all these tasks, we just then run it many times, enough times, and get how are we getting the responses from the machine. So example is suppose the input is what is the weather, and the output it should be and it can give many outputs, right? So it is giving, it is 32 degrees Celsius and sunny. Now it can give any output, like very simple, 32 degrees Celsius only, like that. But we don't talk like that, right? Humans talk very energetically, very actively, depending on the mood, very sad. It depends on the human's mood. But machines don't have the moods. So we just run it and train it on the model such that, suppose we are training it on an angry model. So whenever I ask it a question, and it will give me a response in a very angry tone, like the Monday GPT in OpenAI, right? So these are used in chatbots, report generation, content creation. So let us see the simple implementation flow. Let's take a Swiggy order tracking chatbot. Now the user says that where is my order? Now what happens? NLP first tokenizes this whole sentence, like where is my order, right? Then intent is detected. The the sentiment analysis is detected. So the whole sentence actually gives you the insights that the user wants to track its order. Now, next happens entity extraction. It will take the user ID, order ID to track whether their order is. Then dialog, it creates response. Now comes the NLG, the generator. Your order is on the way, delivery partner will arrive in 10 minutes. Now, it happens wholly on its own. The chatbot is processing everything on its own. This is how NLP works. Now, we can get deeper into NLP for with some codes and show some practical examples in the next session. So, thank you so much for watching.